Ladies and gentlemen, boys and girls, welcome to SciShow Quiz Show. I'm your host, Michael Aranda, and our contestants today are the man, the myth, the legend with his very own butter sculpture, Hank Green.
We're going to show it on screen right now?
I hope so.
Spinning around a little bit?
I sure hope so, because it looks exactly like you.
It does. It's a very good likeness.
And then we have the dairy-free associate producer of SciShow, Stefan Chin.
Dairy-free? I eat cheese all day long.
He's mostly cheese, Michael.
I'm mostly dairy.
I'm just reading what the card says. Sari wrote dairy-free, so I said dairy-free.
Dairy-free. Let's go with dry meat enthusiast.
Okay. And the dry meat enthusiast, associate producer of SciShow, Stefan Chin.
Love that jerky.
Today, Hank will be competing on behalf of Patreon patron Bryce Daifuku,
Hi, Bryce.
and Stefan will be playing for Jonathan Hood.
Jonathan Hood, let's do it.
Now, I'll start.
Let's beat each other.
I'll start both of you off with 1,000 SciShow bucks. Each time you get an answer correct, you will win, say, 100 points.
Sure.
And each time you answer incorrectly, you'll lose, say, 100 points. Whoever has the most points at the end of the game will win some sweet prizes for their patron. Stefan, show our players and the audience what they can win.
Thanks, Michael. Bryce and Jonathan will be receiving signed cards from today's final round with our contestants' final guesses and wagers on them. The winner will, of course, take home the I Won SciShow Quiz Show pin and some secret SciShow swag from dftba.com. But the loser will get the highly coveted I Lost SciShow Quiz Show pin. Back to you, Michael. Go, Stefan!
Our first round is going to see how you measure up to each other, since it's all about how humans and animals measure things. The International System of Units has 7 base units to help humans describe different measurable things, from kilograms for mass to Kelvin for temperature. But sometimes scientists stray from these fundamental units. Instead of saying your blood pressure is 15.96 over 10.64 kilopascals, a doctor would say it's 120 over 80 millimeters of mercury.
Okay.
Because it's hard to change once you started something.
Yes. That's because we used a device called a mercury sphygmomanometer.
Really?
Did I say that
Is that what
correctly?
it's called? Okay.
To measure blood pressure.
Okay.
I believe
With
you.
an arm cuff attached to a gauge full of mercury. 3 of the 4 following units have also been used for a similarly specific purpose. Which of them is fake? Is it barns to describe cross-sectional areas in nuclear physics experiments? Flops to describe how well supercomputers can perform, scales to describe how fractals mathematically propagate, or crabs to describe the intensity of objects in space based on X-ray or gamma-ray emissions.
I know that it's always worse to go first, but I'm going to go with crabs. God dang
You are
it!
incorrect, I'm afraid.
What were the choices again?
Okay, you've got barns, flops, and scales. Do you want to know what they describe?
No, that doesn't help me at all.
Okay.
I'm gonna go with scales.
You are correct.
Oh, Jonathan, we're doing it!
The answer is scales. A barn is 10 to the negative 28 meters squared, which is about the cross-sectional area of the nucleus of a uranium atom. In the 1940s, physicists at Purdue University were trying to come up with a catchier name than the Oppenheimer, and apparently settled on barn because they were in the Midwestern United States. Barns are mostly used to describe the results of particle scattering experiments. Flops, or floating point operations per second, are a way to describe how quickly different supercomputers can do calculations with floating point numbers with decimals in them. And crabs were a unit based on the X-ray and gamma-ray emissions from the Crab Nebula, a dust cloud with a pulsar at its center, which is a spinning dense star. Astronomers used to calibrate instruments based on the intensity of the Crab Nebula at different radiation frequencies. But in 2011, they realized the nebula was fading over time. It might not be as reliable as they thought. Now, animals managed to find their way around the globe without help from roads or Google Maps. We think a lot of creatures like birds have adaptations to sense the Earth's magnetic field. On the other hand, ants are especially good at detecting chemicals, so they might use scents, the sun, and bigger landmarks to guide them. But Saharan desert ants go foraging in vast stretches of shifting sand, and they still don't get lost. In 2006, researchers found that the ants might have another navigation trick up their sleeves. Is it detecting polarized light reflecting off the sand, an internal pedometer, which lets them count their steps and measure the distance, exploring outward from their nest in concentric circles so they can find their way back, or an extra pungent physical secretion that leaves a better trail to follow back?
You go first. You go.
No,
You go.
No, I just wanted to make a show like I was gonna do something, but I really wanted you to do it. So go ahead. Go ahead.
the light on the dunes.
I'm afraid that is incorrect.
Oh my God, I'm having the worst day.
Internal pedometer.
That is correct.
Oh, God. I'm 400 bucks.
Oh yeah,
Oh boy.
we're doing it.
I'm now I got 800 SciShow bucks, Stefan.
I just like the idea that they have a little like Apple Watch or something that they're just like,
Gotta get my steps in.
gotta get my steps.
The answer is they count their steps. To find their way home, ants need information about which direction to head and how far to go. Scientists think they use the sun to figure out which way to go, but this team of biologists wanted to test how they measure distance. They stuck some food 10 meters away from a Saharan desert ant nest and trained them to find it, so the ants were comfortably traveling back and forth. Then, the researchers snatched up 50 ants that had reached the food and modified their legs, either cutting off a segment to make them shorter or gluing on pig bristles to make tiny stilts. When these modified ants were sent back on their merry way, they got lost. The ants on stilts went about 5 meters too far, and the ants with short legs stopped about 4 meters short of the nest. After that, the scientists helped all the ants back to their nest, and when they went out to forage again, they found their way back just fine. And that suggested that they have some internal step counter to help them navigate. Okay, we're on to round 2, which means the point value goes up.
Oh, thank goodness.
This round is about extreme sounds.
Okay.
You're in trouble now.
And this first question is true or false. Movies like Jurassic Park cobbled together dinosaur sounds from a bunch of other animals, from baby elephants to owls to dogs.
I just always thought there was a guy in a room just going like, and then they just mix it all together and push the bass up.
Scientists are learning more about what dinosaurs might have looked like, and they're also learning more about what they might have sounded like. So, true or false? Based on their similarities to birds, a team of researchers predicted that dinosaurs would only have been able to produce open-mouthed bellows and roars.
Sounds sort of familiar.
I feel like we did talk about
Yeah.
this.
Wait, is that? Oh, it's
true or false?
Sorry, I thought.
Is the thing I just said
Okay.
true or false?
I'm so glad you did that.
True.
That is incorrect, I'm afraid. What's your answer?
I think it's false. I think Stefan said true, so I'm
Oh,
going to say
you are
false.
correct. Wow. Good thing you knew that knowledge. The answer is false. This study looked into 2 different ways modern birds vocalize. Many birds open their beaks and make sounds that cover a range of frequencies, but others keep their mouths closed and push air into a throat pouch to make sounds, especially when they're trying to attract a mate or defend their territory. This kind of closed mouth vocalization has evolved separately in birds and crocodiles, which are both evolutionarily related to dinosaurs. So even though there's no direct fossil evidence to let us know what dinosaurs sounded like, some of them probably made these low, quieter, booming or drumming sounds in their throats, maybe like a cassowary. Even though a lot of the universe is empty, some parts have stray bits of dust and gas particles that can act as a medium for sound waves. One of these stuff-filled regions is the Perseus cluster, which contains thousands of galaxies in a cloud of hot gases that are emitting detectable X-rays. Something in the Perseus cluster is producing the lowest sound waves we've ever detected in the universe.
It's a whale.
That's correct. Next question. Okay, is it actually a luminous blue variable star, a hypernova, a hypergiant star, or a black hole?
Shoot. Why did I push the button, Michael? There's a very clear strategy to this game, which is that you are much more likely to get the answer right if you go second. What was the first one?
A luminous blue variable star.
I'm gonna go with black hole.
You are correct.
Hey! Ho!
I was gonna guess the blue thing, so.
All right.
Do we have lifelines? Can we phone my mom or something? Not that she would have known that, I guess.
If
but-
you want to actually call your mother for the next question, I will permit it.
Ooh, what's it about? Baking? She might know the answer to that one. She's pretty good.
It's about haptics. The next question is about haptics.
Can I call you?
Sure.
You know about haptics.
The answer is a black hole. In 2003, astronomers using NASA's Chandra X-ray Observatory were looking at the Perseus cluster when they indirectly detected sound waves coming from the black hole at its center. These sound waves are transporting energy throughout the gas cloud, which keeps it warm and affects how stars and galaxies are forming and changing within it. So looking for sound waves in other galaxy clusters might help astronomers understand how these objects form. The frequency of these specific super low sound waves is so low that it takes 10 million years to complete a single wavelength. As it happens, that's a B flat that's 57 octaves below middle C, 1 million billion times lower than the lowest sound your ears can hear.
Besides visual advancements in virtual reality, there's a lot of research into haptics. That is, the way we can interact with computers by touch. Haptic research covers everything from rumble packs you can stick into your Nintendo 64 controller to the way your Apple Watch taps on your wrist with tiny physical motors. And in 2014, a team of researchers from the University of Bristol developed one way to make it seem like you're touching holograms, even though they're just projected light.
Okay.
What did they use to do it?
Porn.
Yep. Was it infrasound waves, an electromagnetic field, ultrasound waves, or static electricity?
Wow, that's neat.
Say them again.
Infrasound waves, electromagnetic field, ultrasound waves, static electricity.
Push the button. I'm gonna go with ultrasound waves.
You are correct.
Hey!
That is the correct
That's, I think,
answer.
what I would have guessed too.
The answer is ultrasound waves. Ultrasound waves are sound waves with frequencies too high for humans to hear. And like all sound waves, these waves exhibit something called the acoustic radiation force, which is a transfer of energy and momentum from the wave to whatever medium it's entering, in this case, your skin. So the researchers built a sensor that tracks your hand as you interact with the hologram and used the information from that sensor to program a flat array of ultrasound transducers below it. Our sense of touch is strong enough to sense subtle differences in the environment, so these ultrasound waves can make it feel like something solid is pushing back on your hand a bit.
We are entering our final round, which means you guys can get ready to bet some number of points that you have.
Okay.
What are their totals?
Stefan has 1,000 and Hank has 1,400.
You can bet as many of those that you want. The topic of our next question is weird surgical procedures. While you place your bets, we're going to go to commercial
break.
Or not, depending on whether there's a commercial that YouTube has. Also, I'll remind you, I sign your paychecks.
Welcome back from what was possibly a commercial break. So human eyes are complicated little organs with lots of specialized parts. The outer layer of your eye is called the cornea, which protects your eye from dirt and germs and scratches and helps focus light along with the lens.
Okay.
Some people have severely damaged corneas, and sometimes a corneal transplant surgery isn't enough to fix their vision. So an eye doctor might implant a keratoprosthesis, an artificial cornea. Sometimes artificial corneas can be made of durable plastics and titanium, but one very effective technique involves a material from the patient's own body. Is that material epithelial tissue from the esophagus, a tooth, bone marrow, or part of the pelvic bone?
I don't want a tooth. Where are you going to put it? A whole tooth?
I can see.
Did you already write your answer?
I just wrote the letter.
Oh, gotcha. Okay.
Okay,
I
you
almost
guys
told
ready?
you which one I wrote.
And show your answers.
Oh, for tooth.
Stefan is the winner.
What? It's a tooth!
The answer is a tooth. In fact, a tooth.
What? I did it!
The answer is a tooth. The full medical name for this procedure is called osteo-odonto keratoprosthesis, or OOKP, but it's also known as tooth-in-eye surgery. It was first described in 1963, and it's basically as strange as it sounds. A surgeon picks a tooth based on its size and shape, making sure the bony tissue, called dentin, and the mouth tissue around it are healthy. They extract your tooth, along with the root and some of the bone beneath it, cut off a slice, drill a hole in it, and add some optical equipment. Then they re-implant it into your cheek, right below your eye, so that the tissue stays alive. Meanwhile, part of your mouth tissue is transplanted onto the damaged eye. A couple of months later, they perform another surgery to tuck the tooth cornea into your eye, and there you have it. Turns out it's one of the most successful and weirdly creative methods to restore vision.
Well, I'm glad I didn't invent anything, because at least that way I got to keep some of my SciShow books.
Am I fired?
So congratulations to Bryce and Jonathan for supporting us on Patreon, and thanks for joining us on this episode of SciShow Quiz Show. If you'd like to support us and help us make more episodes like this, you can go to patreon.com/SciShow, and don't you forget to go to youtube.com/SciShow and subscribe.
Oh yeah.
A tooth.
Jonathan had good mojo.
Sorry, Bryce.
Got me there.
In 2014, you two faced off, and Reed won. And then in 2015, you guys faced off, and Hank won.
I don't remember
And
anything.
today,